Okay, so on 7 and 8, we are determining the domain and the range, and is this a function or not. So when we go to write the domain, though, it's the x values. So the first values on all of these, and we have 3, -5, and 5. And this is another 3, and we never put the same number in it twice, so just once. Once is enough. And our range is 5, repeated 5, 9, 18. And then since the x value did repeat on this, because we had 3 and 3, this one would not be a function. Our domain on this one is 6, 7, 8, 9. And the range, our y value, is the same, so it's just -1. And since we only care about the domain when we're deciding if it's a function, this one is a function. Determine whether the equation defines y as a function of x. So there's a little trick or rule to this, whatever you want to call it. It's not a function when y is squared, or y to the 4th power, y to the 6th power, just the even exponents though, or we have the absolute value of y. And the reasoning behind that is we know that x squared is a parabola, and so is y squared, except when y squared is a parabola, it's turned on its side. And when we have functions, we can do a vertical line test to check and see if it is a function. And if it hits the graph more than one spot with the vertical line, it is not a function. And the reasoning, or why, is because if I wrote down these points, which I'm going to make up, we'll say this one is for +2, and this would be for -2, and they share that same x value, and that goes against the definition of a function. It shares the domain value. So this one is a function, where x equals y squared is not a function.